So here's just finding the average and the standard deviation. Maybe towards the end, I'll show you how to calculate the standard deviation by hand. It's quite tedious, but your average should be seven scores, right? So I don't know, I would put down points, and the standard deviation is 10.95 points. So pretty straightforward. That's what you should have gotten. 2 marks for that, 1 for each. Why not? All that space, what for? Well, I sometimes make you do it by hand. So that's why I leave the space there. Next, you have test score results, and there's a frequency table, and you see that there are intervals, and you should have figured out the midpoints, right? I hope that by now you know that. So you're basically choosing to enter the average, right, for the actual score. So you would get 1 mark for figuring that out. Okay, and then to figure out this, it doesn't hurt, right, to indicate that this is what you've done. And the average there is 63.33%. The standard deviation is 15.29%, and the class size is 30, right? Otherwise, you would have had a class size of 10, right? So your N, right, should have 30 students as part of your sample, right? That's your sample size, right? It's also called N, right? N is equal to 30. In this case, it represents the class size, the number of students that were considered for this frequency table. So 3 marks for all of this, right? Midpoints, and then figuring out that. So this page is worth 5. Oh, by the way, complete aside. Now that you have your mean and your standard deviation, you could come up with you could make a normal distribution as well. You could do that, right? You add standard deviation as you go to the right, you subtract as you go to the left. You could do that. You could transfer this information into this, right? Which we will do later on. Okay, so it is possible. Once you have your standard deviation and your mean, you could transfer that to a normal distribution curve. Tough one, right? Explain the meaning of standard deviation. How is it helpful in interpreting data? So the meaning, right? One way of describing it is the average distance of all points from the mean. And you're like, what? That's actually, if you go into your notes, I underlined that and highlighted. That would be one of the definitions of mean or of standard deviation. You can also say it measures how spread out, right? How spread out the data is, right? How far away from the mean your data is. You can put that down as well. How is it helpful, right? A large standard deviation, right, indicates inconsistency, right, within points, sorry, within data, right? A small standard deviation indicates consistency within data. That's another way of putting it. You can also say that a large standard deviation will coincide with a bigger range, and a small will have a smaller range. You can also, because it's specific to how is it helpful in interpreting data, right? So an athlete, right, you would want a small standard deviation because it indicates consistency. Anybody not sure? If you want me to look at yours, just indicate that. But for now, give yourselves a mark there, and then just tell me at the front. Don't tell me at the back, right front of the paper. Look at it, please. Damon, you had your hand up. Would you mind? You have a question for?
Yeah. Oh, I just put like it's helpful to more data points.
It's helpful to know where the data points will be. If you had said it will help us to know whether data points will be closer to the mean or further from the mean, that'd be more specific. So I would give you half for that part, for the interpreting part. Yeah. So standard deviation tells you how far or how close from the mean points are by definition. And how is it helpful? Well, if it's a small, then it indicates consistency. Everything will be clustered around the mean. Okay. If I could, I actually spent a significant amount of time putting this together so you would have it all in one. If you go to page 3, right, it basically, this whole page is dedicated to standard deviation and how the graph will look, right, all of that. So maybe take a look at that as well. Okay, next we have our curve. Allow me to just show you the completed curve just to speed things up. So look at those values, and obviously we couldn't label because we didn't know what they were, right? So did you put z-scores? I didn't tell you to put z-scores, so if it's missing, it's okay for today. But this would be the z-scores. And really all you need is these values along the x-axis. If you have these values along the x-axis, you get 1 mark. If you have the correct percentages in between, you get another mark. And the third mark will just be like, does it look like a bell curve, right? Does it have like a highest point and then taper off? So if the graph is there, you get 1 mark. 1 mark for the correct values along the x-axis, and 1 mark for the percentages inside each interval. Okay? B? D, yes. I will do that here. Let me just have my graph ready because I'm going to use that to answer. So I'll do B, C, and then D. D is the tougher cookie there. So state the percentage of data points between negative 0.45 and 1.8. So we're looking at between here and 1.8, right? Anywhere in between here. Watch how I do this. 1.8 is right in the middle. So I know that everything to the left is, what percentage of data points would be to the left of the middle? 50, right? So I just do this, 50% minus this little sliver here. And that gives me 49.85%. Right? You could have also just added, right? This, and this, you get the same answer, right? I hope you get the same answer. Otherwise, you have the wrong percentages. But sometimes it's easier to just be like, everything is 50, take away this, and then it will leave you with the remaining percentages. Got it? Next, state the percentage be greater than negative 0.45. So that's right here. So you want everything to the right of that. So watch what I do. I know that the whole curve is 100%. I will just subtract this one to give me 99.85%. So either you add them all up individually. By the way, you should at least know this. This should be 50, right? Plus 34 plus, right? To speed things up a little bit. But it's 99.85% of data points. And now the tougher one. Let me just cover that up. Let's see here. If there are 12, it's almost like saying if there are 2,000 households that we're considering or whatever, in this case it's 12,000 data points, how many would have a z-score of less than -2 and greater than 1? Okay, so this 2 standard deviations to the left, that corresponds with a z-score of -2. So you want everything to the left of that, right? That's what one part we're considering, and that is 2.5%. Okay, less than z of -2, that would be 2.5%. Do we agree on that? Yeah. Greater than 1. 1 is right here, so this adds up to 16%, right? This is a z-score of 1, so 16%. So we wanna okay, like if this is 2.5 and this is 16%, then we are actually talking about 18.5% of data points that we're considering. 1 mark for that one. So if you have 18.5, boom, you get a mark already. Now I need to figure out how many, right? How many? So you go 0.185, you turn that into a decimal, and then you just multiply that by 12,000 in this case. Why do I put $sign? I don't know why. That's 2,220. You get another mark for that. So you get a mark for the 18.5, and you get a mark for the 2,220. All right. All right. So add it all up. This is it's going to be out of 12, and I'll tell you why. So this is worth 2, right? 2. This backside is 2, and 3 is 5, 6, 7, 8, 9. So the backside is worth 9 marks. And then let's go to the front. The whole thing is 5, right? So 9 and 5 is 14. So we'll make this whole thing out of 14. Francis, did that make sense? The 2,220? Okay. So pass it forward, please, and then back to the notes. Have your calculators ready to go. Maybe I'll just leave this